Today we are going to discuss about nuclear chemistry radioactivity. Radioactivity, when the strong force is not large enough to hold a nucleus together tightly, the nucleus can decay and give off matter and energy. This process of nuclear decay is called radioactivity. The elements whose atomic nucleus emit radiation are said to be radioactive. The spontaneous breaking down of the unstable atoms is termed radioactive disintegration or radioactive decay. The disintegration or decay of unstable atoms by emission of radiation is called radioactivity. Nuclear decays and reactions. When an unstable nucleus decays, particles and energy called nuclear radiation are emitted from it. The three types of nuclear radiation are alpha, beta and gamma radiation. Alpha and beta radiation are particles. Gamma radiation is an electromagnetic wave. The rays which are deflected towards the negative plate are positively charged and are called alpha rays or alpha particles. These rays consist merely of helium nuclei. Beta rays. The rays which are deflected towards the positive plate are negatively charged and are called beta rays or beta particles. These rays consist merely of electrons. Gamma rays which are not deflected at all, neutral. Nuclear fission. Nuclear fission is the process in which a large nucleus split into a smaller nuclei with the release of large amount of energy. Example, fission of uranium-235 by neutrons and atomic bomb. If uranium-235 is bombed with a slow moving neutron, unstable uranium-236 is formed. Then the unstable uranium-236 split up into barium-141 and krypton-92 with the release of neutrons and large amount of energy. Heavy nucleus like uranium-235 and plutonium-239 is bombed with slow moving neutrons, splitting them into two or more smaller nuclei. Two or more neutrons are produced due to the conversion of small mass of nucleus into energy, and it releases enormous amount of energy. The product of the reaction are radioactive in nature. The energy released in one fission reaction is different from energy released in another fission reaction. The bomb, which works on the principle of the fast nuclear chain reaction, is referred to as the atomic bomb. Temperature developed in an atomic bomb is believed to be a million degrees Celsius. Besides, many radionuclei and heat delay gamma rays are released. Little Boy was the first nuclear weapon is used in warehouse. It is exploded approximately 1800 feet over Hiroshima, Japan, with a force equal to 30,000 tons of TNT. Fat Man was the second nuclear weapon used in warfare. Dropped on Nagasaki, Japan, Fat Man devastated more than 2 square miles. Nuclear fusion. Nuclear fusion is a process in which two or more lighter nuclei combine to form a heavy, highly stable nucleus with the liberation of large amount of energy. When two deuterium atoms are heated to a very high temperature, they fuse together to form a heavy nucleus of helium with liberation of large amount of energy. Nuclear fusion reaction in Sun. The pressure inside the core of the sun is very high and it pushes the hydrogen atoms close to each other. The two hydrogen atoms combine to form a bigger helium atom with a release of large amount of energy. This process takes place in multiple steps. The net energy released is 26 millielectron volt. These reactions are responsible for 80% of the sun's energy. Carbon dating. Carbon-14 has a half-life of 5730 years and is found in molecules such as carbon dioxide. Plants use carbon dioxide when they make food, so all plants contain carbon-14. This method was developed by Wilfred and Libby to determine the age of wood and animal foils. This method is based on the fact that the radioactive isotopes of carbon-14-6 is formed in the upper atmosphere by reaction with neutrons from cosmic rays. The carbon-14-6 atom thus produced are rapidly oxidized to carbon dioxide, which is incorporated in plants as a result of photosynthesis. The ratio of the number of carbon-14 atoms to the number of carbon-12 atoms in the organisms remains nearly constant. When an organism dies, its carbon-14 atom decay without being replaced. The ratio of carbon-14 to carbon-12 then decreases with time. By measuring this ratio, the age of an organism's remains can be estimated. Only material from plants and animals that live with the past 50,000 years contain enough carbon-14 to be measured. The amount of carbon-14 or the number of beta particles emitted per minute per gram of carbon at the initial and final stages. The age of carbon material can be determined by the following equation: T equal to 2.303 T divided by 0.9693 logarithmic amount of carbon-14 in fresh wood divided by amount of carbon-14 in the dead wood. This method has proved to be a great tool for correlating fact of historical importance. It is very useful in understanding the evolution of the life and rise of full of civilizations. Thank you.